Well, now it's time to dive into this thing and see if we can figure out what's going on with this check engine light and figure out this Valvetronic issue it's got. All right, full disclosure on this diag. Yeah, I might be wrong. I have no idea. I tried finding a known good of the waveforms that I took. No luck. So if you're a BMW guy and you have these waveforms, shoot me an email. But let's get into it. So I've actually switched over to the Autel because for some reason it gives a little better information about this code, this 2DD6. All data doesn't say anything about this code. You Google search this code, you find a lot of other Valvetronic codes, but not this one particular. And I was really wanting some information about it. But Autel comes through with this service manual button on BMWs. And it gives you some basic brief information about this code. And yeah, it's basically just telling us there's a fault with the circuit. But down here at the bottom, possible solutions, it gives us another code. So this 135808, if we go over to the all data and punch that code in, 135808, we actually get a code and description. And it matches basically kind of what all this up here is saying as well. So we're going to go with that code and go over all this information. All right, so we've got the 135808 code here pulled up, and it's basically telling us the same thing that the 2DD6 code is: Valvetronic servo motor position sensor circuit, short circuit or line break open circuit. So not a whole lot of information, but it's telling us there's a problem with the position sensors that it doesn't like. And all this other stuff is basically what's in the scan tool there in the Autel. So not a whole lot of help there, but we wanted to pull up a diagram, and that's where this car kind of threw me off and had me a little confused. I'm pretty good with wiring diagrams. I've been working with wiring diagrams since I was probably 13 or 14. Basically started learning them in high school. Anything from basic house wiring diagrams to PLC ladder logic diagrams. Some of you may not even know what that is, but it's motor control diagrams for industry and robotics and things like that, all the way up to automotive diagrams and things like that. But the diagrams for this threw me off, and they are on all data. They're easy to find, and there's only one set that it shows for this car. So under the OE, we go down here to the powertrain, of course, and gear valve. That's what they kind of refer to the Valvetronic, the gear, the valve gear, whatever. And here they are. All data breaks them into sections like this, and it's kind of hard to follow them, but right here is our Valvetronic. So this diagram threw me off, and I wasn't even sure it was right. So I actually purchased BMW subscription to get Air, and Air gives it all in one diagram here. So this is it, and it's the exact same diagram. What threw me off was here it shows basically a terminal 15 power input, and we can see that this right here is the motor position sensor, and then this is our Valvetronic servo motor here. We got 3 wires going to the motor. We'll get into that in just a little bit. and then we've got all these other wires coming out here that go back to the DME. So from this diagram, it looks like DME supplies terminal 15, which, if you know BMWs, that's ignition basically to this. And then down here we've got this weird icon, this one, and this one. And to me, just looking at this diagram, this would appear to be the ground to me. This resistor and this right here to me looks like just a way for the DME to monitor that circuit. Same with this up here. So if you've got terminal voltage going through a resistor and then the ECM is sampling it right here, it can know if this output is shorted to ground or not. So to me, that's same with here. We've got a little bit of a resistor before the actual ground inside the ECM, and it's monitoring that ground for maybe a short voltage or something like that. So it's kind of how I interpret it. Power in, power out, and I don't know what this is or this, but I'm assuming some kind of the signal input, some way it monitors it, maybe. Could be like a pull up or pull down kind of thing, and it's monitoring it. And then we've got the other 3 wires here that don't seem to go to anything in the ECM. So this diagram threw me off. And testing the car, I actually determined that this is actually 5 volts and this is actually my ground. These others are my signals. And the way BMW labels these, like this UBLDCS, MBLDCS, and these right here, S1, S2, S3, S4, S5. That's kind of the better way to go about this and checking this. This M is supposedly means ground most of the time, and this U is power of some sort. And yeah, this diagram just threw me off, and what I was checking, the car was actually pretty easy to diag. We're going to get into that. But this diagram just threw me off. So if anybody can explain this, leave it in the comments. I want to know why they do this. Like, to me, this looks so wrong. But anyways, that's that. So here is the 5 volt. I did find service information says this is a 5 volt circuit, so I did find the 5 volt feeds here that come over to the Valvetronic. You can see here they call it 15, but then in the brackets here they say it's 5 volt 1. Over here we got 5 volt 2, and then on across the page there's a 5 volt 3. And I found this information going into component descriptions, and here we've got another thing that threw me off. We got valve gear 1, valve gear 2. So, and I went into valve gear 1 first, and it shows us our servo motor here. And I basically just read through all this and basically determined this is not the gear that I have. So there's up to 3 generations. Generation 1's not even listed in here. This would be a generation 2 Valvetronic, and then there's another generation 3. And the way I determined that I have 3 is basically looking at the Vano solenoids. My Vano solenoids do not look like this. So if I go back over here to gear 2, we can scroll down here and see that these Vano solenoids look completely different, and this is what this engine has in it. So then I can make the assumption that this is the Gen 3 Valvetronic servo that I have in this car. And this is where I basically got the information that let's see, where was it at? It tells about the sensors. Okay, yep, right here. The servo motor is supplied with 5 volts. So the sensors are supplied 5 volts, and there's 5 sensors. And 3 of them are used for approximate identification, and 2 are for details. Basically, to make this very accurate, it's using 5 sensors. 3 get you in the general ballpark, and then 2 sensors really dial in where that thing is at. So this is what I found that says, oh, well, this is 5 volts. And then I found the diagram for the 5 volts in air. And that's about all I really found on this. The whole ground thing was still throwing me off, so I reached out to Justin Morgan, a phenomenal BMW knowledgeable guy, and he's like, I'm overthinking it. Just accept that this is ground and these are the five sensors. So basically confirmed what I already thought in my diagnosis, and the diagram just really threw me off. These down here just threw me off for a little bit, and I don't understand it. So if you're a BMW guy and you know why these are labeled like this in the DME, let me know. So I'm curious. I want to know if this is just wrong. To me, this is just wrong, but either way, let's get into checking this car, see what's wrong with it. So I have the cover pulled off here to just get some access to it. And you can see we've got 3 wires across this top row, 3 wires in this middle, and then 4 wires in this bottom row. And our diagram showed blue being as power, and then of course we figured out that black is our ground. So first thing I did was checked those. So let's just back probe this in here. Alright, so these things are really aggravating to get back probed. Those terminals are like really deep in there, but we're in there. We've got the 5 volts. Let's put our little test slide in here, and we see it drops down just a little bit, but we're lighting the bulb up, and part of that might be even my connection here, because it's really finicky. Like just wiggling this around, you see it drops out. These are hard to back probe. So yeah, we've got our 5 volts there. So now let's start checking these 5 sensors and see what's going on with them. And I'm actually going to just pierce probe the rest of this because they're super aggravating to back probe, and make it just a lot easier and our test more valid doing it that way. Alright, so I've got 4 channels from the scope hooked up. Channel A is in sensor 1, channel B is in sensor 2, channel 3 is in sensor 3, and channel 4 I've just got in the 5 volts reference there. And on the scope here we can see channel 4 is at 5 volts. Everything else seems to be just off of ground a little bit. And the way this servo works is anytime you turn the car off and then crank it, it actuates it to try to relearn if it's got a fault. So I'm going to get in the car and crank this thing and see if we get some movement when it first starts to crank and do that relearn. So got the key out. Let's put the key in and wait till the scope gets to the next page. And there we go, we got some noise, probably from my ground. Let's stop this. Go back. Okay. Let's turn this car off. We did get something there, so we'll turn this off. and see what we got. Everything's cleaned up, and wow, as you can see, oh yeah, it does that. That's it trying to relearn or something. That's the servo motor. So I know the servo motor's got power. But if we look at this, what do we see? Well, come on. There we go. Our 5 volts stayed relatively at 5 volts. Our channel A, you can see something happening here. Same with channel B. You can see basically they've got the same thing going on. But channel C, this is like what we'd expect. Let's get down here. It doesn't quite make it to 5 volts. I don't really worry too much about that. As long as it's within a half a volt, I'm usually fine. So yeah, 4.5. I'm fine with that. The reason is because some of these sensors and things utilize a diode. Diodes have at least a half a volt drop almost always. So I'm not too worried about this. The computer's not going to be sampling it that high. It's probably going to be sampling it around here in about the 3.5, 3.6, you know, somewhere around in there. It's going to be sampling in a different place than right at the top or the bottom because of that reason. So this sensor looks good. This sensor, these two sensors look like garbage. So let's see what our other two let's see. Oh, yeah, we got 2 more sensors. Let's check those other 2 sensors now and compare that to this. All right, so I went ahead and done the same thing. I've moved channel A and channel D to sensors 4 and 5, and on the scope capture here we can see our channel B is still on sensor 2, so we've still got this weird looking waveform here, but the other sensors seem to be working just fine. If we zoom in here, let this kind of clean itself up, you can see our channel A is now on sensor 4. Okay, that looks like a good pattern, and then channel D is on sensor 5. That looks like a good pattern. I don't know what these patterns are supposed to look like, but sensors 1 and 2 having this looks really strange to me, and I don't like it. I think they should be a full 5 volt square wave, basically like these are. And yeah, I don't like that. And I don't know that I've even got a known good for this, but I'm calling it a bad sensor based on that. These could be being pulled to ground. So let me move my one scope lead back over to our other bad wire here, or suspected bad wire. Let me save this. So our sensors 1 and 2, you can see are low voltage right now. So is our sensor 3 and 5. Sensor 5 is still floating about 4.5 volts. But we know these should be pulling up to 5 volts at least, or have that range, we think. So let's unplug this and see what happens. And everything goes up to 5 volts. So if we move this cursor up here, so there's our 4.7. That one is still showing, oh no, 4.6, okay. Let's move her. cursor over here out of the way. So there we go. Everything's 4.5 volts, 4.6 volts. So like I said, a lot of times those things will go through a diode or some kind of protection circuit that's going to reduce that voltage down a little bit, and that's what we're seeing. We're seeing the DME is sitting about 4.6 volts is what everything's coming out of it, and these sensors are then going to be pulling that voltage down, giving us a square wave. So I think sensors 1 and 2 are internally shorted to ground or have some resistance to ground, and that is why they're not getting back up to that 5 volt plane or 4.6 volt plane and correctly reading. So that's my diagnosis. I don't think this is a DME issue. If this was a DME issue, unplugging that, I would expect those voltages to still stay low, and if they were still low, I could then take 5 volts, feed it through my test light, and try to pull that voltage up and see if it could pull up. If it wouldn't pull up, then we would think, okay, our problem's either in the harness or the DME that's got it pulled to ground. So like I said in the beginning, not really a whole lot of interesting things here, but that whole service information stuff kind of threw me for a loop on those diagrams, and didn't make a whole lot of sense. But I think we've got a solid diagnosis here that this thing has bad position sensors in the Valvetronic motor, and this one is not an easy one to replace. Is very time consuming and very expensive. So this car is going to be going to the sale like it is, and somebody else will have the joy of fixing it or not. I don't think it actually sets the check engine light on. It may after so many failed cycles or something, but right now the check engine light is off. The code is set. Even on the scan tool here, does it say on the scan tool? No, I think it just in all data it gives us that it does not turn the check engine light on, and it basically runs in emergency mode or something like that. So let's pull that back up real fast. So driver information, warning lamp off, off, none, off, off, and none. So like I said, if this fault happens, it basically just doesn't even matter, apparently. So we'll just send it like it is, and somebody else can fix it if they want to. So thanks for watching, everybody, and we'll see you guys later.